Hi and welcome to this video, which is going to go over the solutions to the first preparation sheet for Maths Paper 2 assignment. So let's jump straight into it. And section 1 was about transformations. And on this grid here, we can see a triangle's been drawn. Okay, and first thing we're being asked to do is draw a reflection of the triangle in the line x equals minus 6. So when we reflect a shape, we need a mirror line in order to reflect it. So the first thing we need to find is where x is equal to minus 6. Now if we go along the x-axis here, we can see that x is minus 6 at this point here. And x has a coordinate of minus 6 all the way along this vertical line. So the first thing we're going to need to do is we're going to need to draw in this mirror line. So I'm only going to draw it to here because I'm going to reflect this triangle on the other side here. But this line does go all the way through. So I'm going to label it x equals minus 6. Now to reflect this shape, this top corner of the triangle, if I go across to the vertical line, it goes 2 squares across. So on the opposite side of the mirror line, I'm going to need to go 2 squares across and mark where that point reflects to. And I'll do the same with the other 2 vertices on the base of the triangle here. So the first one, this corner, again, is 2 squares to the mirror line. So I'm going to go 2 squares past the mirror line, and the final one is this corner here, which I need to reflect. Now if we count across, it's 4 squares across to the mirror line, so reflecting that needs to take it 4 squares past the mirror line on the other side. And as we can see now, we've got our 3 corners and we just join them together, and that is our reflection there. Being asked to label it A, so just put a letter A into the triangle. Okay, part B then is asking us to draw a reflection of the triangle in the line y equals x. Now y equals x is a vertical line, and if we think about it in terms of coordinates of xy coordinates, this is where the y coordinate is equal to the x coordinate. So like here's 0, 0, 1, 1, 2, 2, etc. So that's a way of remembering the line y equals x. It's a vertical line. It's a diagonal line, sorry, that goes through 0. So just drawing it carefully here, as we can see, that's the line y equals x. It can be extended as well. So again, what I will do on this one, just choose a different color pen this time so we can see that what I'm doing here with each vertex. So first of all, I'm going to come to this corner here, mark it with a blue dot. And this time, because it's a vertical line, we go across to the mirror line, so we need to count across. But then because it's diagonal, it reflects it to go down. So the reflection will be down in this area here. So I'm going to count across 1, 2, 3, 4, 5 squares across. So I'm going to count 1, 2, 3, 4, 5 down. So that corner reflects to here. Right, let's pick this corner next then. So again, counting across to the mirror line is 7. And we're going to go 7 down. Takes us to here. So there's my second point, and finally is this one, and it's furthest away from the line y equals x. You just need to take care that we count the right number of squares. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we need to go 11 down. So 7, 8, 9, 10, 11. Again, now once we've got our 3 corners, we just join it up. There we go, and we label it B, and that's how to perform a reflection in a diagonal mirror line. Okay, this is about translating shapes then, so it's about moving a shape. So if we remember our column vectors, x, y, the top one tells us to move across, and the bottom one, y, tells us to go up or down. Okay, so it depends on the information in here. So we've got a triangle here, and we're being asked to translate it using the vector 8 minus 2. So 8 minus 2. 8 is positive, so we're going to go 8 to the right. And the minus 2 is negative, so we're going to go 2 down. So again, just pick one corner this time in your shape. So I'm going to pick this top corner here, and I'm going to move it 8 to the right. 1, 2, 3, 4, 5, 6, 7, 8. And I've got to move it 2 down. So it now moves to here. And then the other corners follow suit as well. So this one will move 8 to the right and 2 down. The shape size doesn't change. This one will move 8 to the right and 2 down. And there's my 3 corners. So just join it up, and I'm going to label it C. Okay, let's have a look at the second one now. And it's asking us to translate the shape using this column vector, minus 2, minus 5. Now, minus 2 It's negative, so it's going to go left 2. And minus 5 means we're going to go down 5. So I'm going to use the same top corner, but this time I'm going to change the color of my pen. So I'm going to go left 2 and down 5, 2, 3, 4, 5. So there's the top there. And again, do the same with this. Left 2, down 5, left 2, down 5. And you can see the vertices give us exactly the same shape. On this one, I'm going to label it D. And on part E then, I've been asked to write down the column vector that gets triangle D onto triangle C. So that means we start with triangle D and we go to triangle C. So here then, again, we've got our 2 triangles already in position. So how do I get from this top corner of this triangle to the top corner of triangle C? So we count. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 squares to the right, and 1, 2, 3 up. So it's 10 right and 3 up. But we've been asked to put it into a column vector. So as a column vector, it's 10, 3. Okay, the nth term then. So on this one, we've been asked to generate a sequence, and we've been given n squared minus 5 as our nth term rule, and we've been asked to write down the first 4 terms. So remember, just substitute n equals 1 in to generate your first term. So 1 squared, take away 5. So that's 1 take away 5, which is minus 4. Then substitute n equals 2 in. So that would be 2 squared, take away 5. So we substitute the values in this part for n here. So 2 squared is 4, take away 5 is minus 1. Substitute n equals 3 in. So that would be 3 squared, take away 5. So 9 take away 5 is 4. And finally, because we want 4 terms, we need to generate this one. So 4 squared take away 5. So 4 squared is 16. Take away 5 is 11. So the sequence will look like this for the first 4 terms. Okay, section 3 then, this is all about how you type in your information in the calculator in the correct way. So we've got an equation, 5x cubed, take away 2x minus 60 equals 0. And we're being told that a solution for x lies between 2 and 3. So it's going to be 2 point something. So the first thing with these types of questions is to get yourself a table drawn up ready to put your information in, the information that you type on your calculator to help you solve this problem. So we want what x values are going to be in this first column. So we're going to put in 2 and 3 first, because they're the 2 values we know it lies between, because it tells us in the question. And then we need to set up our calculator in the correct way. So where we have x, we need to substitute. So when x is 2, I need to substitute 2 into this x here, and I need to substitute the 2 into this x here. So I'm going to need to type this in this manner on the calculator. So it's the 5, and then it's times the 2 cubed. It's not the 5 that's cubed, it's the 2. It's the x that's being cubed, so that's 2. You could type in 5 times 2 cubed. I always put all my substitution parts in brackets, whether they're positive or negative, because the calculator is less likely to make a mistake, especially with a negative number. And then we come to this part here, so 2 times the x, so 2 times 2, take away 60, and then write down your solution to that. So hopefully if you did that, you have minus 24. And that's smaller than 0, so we're going to put that it's too low or too small in here. And then we go back to the calculator and we substitute 3 in instead for x. So notice how it's the values in the brackets that are changing. So substituting in them will get you an answer equal to 69. So as we can see that this time is too high. So we know it's between 2 and 3, so it makes sense to try the middle, and then we can go up or down from the middle. So just substitute this time 2.5 into the brackets, into the equation. Type it in on your calculator. So for on this one, I've got 13.125, which again is above 0, so it's still too high. So I know that now I'm going to be lower than 2.5. So my answer is going to be between 2.5 and 2. Now at this stage, I always go one step at a time so that I avoid missing something important. At this stage, if you're happy you've got your calculator set up, you don't have to continue writing it out in full. You can just amend it on your calculator and substitute it in. So for this one here, just a check for you, it comes out as 4.32. In this case, it's still too high to solve the problem. I'm going to go slightly lower again to 2.3. Type that in on my calculator. This time it's negative. It's minus 3.765. And this time it's too low. So we started off and it was between 2 and 3. And now we are between 2.4 and 2.3. So our answer lies somewhere between 2.3 and 2.4. So we always check the middle here to see which way we need to go from 2.35. And then it'll tell us our answer correct to 1 decimal place, which is what the question is asking. So we're going to try 2.35. So replacing in our brackets with 2.35 gives me an answer this time of 0.189375. So we're getting very close to 0, but it's positive, so it's still too high. So if we're still too high in the middle, our answer is going to be in this space here. So is it closer to 2.3 or 2.4? Clearly, it's closer to 2.3. So we just make a final statement that x is equal to 2.3, correct to 1 decimal place. And that's it solved. Right, question 4 then is all about straight line graphs. So we need to use the formula y equals mx plus c. We're being asked to find the equation of the straight line, okay, shown in this diagram. The m tells us the gradient of the line, and the c tells us the y-intercept, where the graph crosses through the y-axis. So c is quite straightforward to find. It's here, crosses through here, positive 6. So the c is 6. We need to work out the m. So we need to find the gradient. So in this case, we need to find and make a triangle using 2 nice coordinate points. So where the line goes through the corner of the square, and then we form our triangle. And then we can see here that 2 squares across, 6 squares up, and it's the difference in the y's. So that's the 6 divided by the difference in the x, which is positive 2. So it goes across 2 and up 6, both positive. 6 divided by 2 is 3. So the gradient of this graph is 3. So our equation for this straight line in this form, y equals mx plus c, is y equals 3x plus 6. On this question, then, we haven't got no graphs to show it, but we know that if lines are parallel, they will have the same gradient. So we need to have the same gradient for the lines to run parallel. So if we have a look at this first straight line equation, y equals mx plus 4, this one's got a gradient equal to 4 because it says 4x. But this equation here is not set up in the form y equals mx plus c, so it's much more complex in order to find what the gradient is. So in order to find out what the gradient of this is, we need to rearrange this equation so that it ends up y equals. So first of all then, I'm going to remove this minus 8x, and I'm going to add 8x to both sides. So it gives me 8x plus 10 on the right. We've already got 10 on the right hand side of the equals. And here I don't want 2y equals, I only want y equals. So I'm going to divide through the equation by 2. So dividing 2y by 2 gives me y. And I'm going to divide both of these terms by 2 as well, giving me 4x plus 5. We could see that the gradient on this graph is also equal to 4. Therefore, the lines are parallel. Okay, and we've supported our answer by showing that the gradient on each one is 4. Question 5 then is about relative frequency, and in here a potato producer wants to test his potatoes to see whether they're oversized. So he tests the potatoes for the relative frequency of oversized potatoes passing through the machine after 100, 200, 300, 400, 500 and 600 potatoes had gone through the machine. we could see here on the right that the results are plotted in a relative frequency graph. So this point here, after 100 potatoes were checked to see whether they were oversized, the probability of that was 0.4, the relative frequency. So we are being asked on this one to work out how many of the first 500 potatoes tested were oversized. So we need to find the correct point on the graph, which is this one here. And it tells us the relative frequency was 0.4. So 0.4 times 500 will get us how many potatoes were oversized. It's 200. Right, one of the most commonly asked questions with relative frequency is, what is the best estimate for the probability based on the trials that were performed? Well, this is always the probability or the relative frequency after the largest number of trials have been produced. So it's this point here. So on this one here, it's this position here, we need to know what the scale factor is, because we know it's between 0.4 and 0.6. So this point here in the middle is 0.5. So between 0.4 and 0.5, there are 5 small squares. So each small square is going to be 0.02. So it's going to be 0.4 plus 2 lots of 0.02. It's going to be 0.44. And we're being asked to give a reason. So the best estimate is 0.44. And it's because it is the results after the most trials, or the most the biggest number of potatoes that were tested. Question 6 then is about factorizing and solving a quadratic equation. So here we have got a quadratic equation. Factorize means to put back into brackets. We've got 3 terms. So it's very unusual only to have one bracket with 3 terms, but check to see if there are any common factors. There are not in this case. So we need 2 brackets. And to make our x squared, we need an x at the front of both brackets. Now, we need 2 numbers that multiply to make 18. And we know, because there's a minus in front of the 18, the signs in the brackets are going to be different. So we need a difference between our 2 factors of minus 3. So that's what we're looking for. So 1 times 18 will give us 18, but they're not different by 3. 2 times 9. They're not different by 3. 3 times 6, well, they are different by 3. And 3 take away 6 is minus 3, which is what we've got here on our middle term. So 3 take away 6, and that's positive 3. So we've now factorized the expression. Now we're going to solve it. So now it brings in what this means is we want to find what value of x is, in this case, to make the equation equal to 0. So these brackets get multiplied together. So to multiply something together to get an answer of 0, it has to be 0 times something, or something times 0, or possibly 0 times 0. So one of these brackets must be equal to 0. So either x plus 3 is equal to 0, in which case minus 3 plus 3 is 0. So x will be minus 3. Or x minus 6 could be equal to 0. In this case, 6 take away 6 is 0. So x could be equal to 6. So we've got 2 solutions. X is either minus 3 or positive 6. Section 7 then about fractional equations. And here we can see that on the left-hand side, we're adding 2 fractions together to get the answer on the right-hand side. And when we add fractions, we need a common denominator. So the first thing we need in here is common denominator for 2, 5, and 5. That common denominator is 10. Or it could be 20 or 30, but the lower common multiple here will be helpful because it makes our work more manageable dealing with smaller numbers. So what do we times 2 by to get to that 10? Well, by 5. So we're going to multiply the numerator value by 5. So that's going to be 15x, take away 5. 5 times 2 makes the 10. So we're going to multiply the numerator through by 2, giving me 2x plus 4. And the same with this 5. I'm going to multiply the numerator by 2, giving me 16. Now we can remove the fractions, because all we ever do in this case, because they stay the same, is add the two numerators together to get the 16. So we remove the fractions. So 15x take away 5 plus 2x plus 4 will give me an answer equal to 16. Now we want to simplify this left-hand side. So we want to collect the like terms. So to simplify this, 15x plus 2x will give me 17x, and minus 5 plus 4 gets me to minus 1. So it simplifies to 17x minus 1 equals 16. Now I can solve the two-step equation. So add 1 to both sides. So 17x will equal 17. And then the final step is to divide 17 by 17, which is equal to 1. So x equals 1. By enlarging a shape then, especially on higher tier, sometimes we see these negative scale factors, and we need to know where the center of enlargement is going to be. So the half is going to half the shape. So we know this shape's going to end up being smaller, but it's going to be a similar shape. And we need to find the center first. So 3 minus 2 is this coordinate here. What we're going to do is we're going to deal with each coordinate, each corner of the triangle one at a time to see where it goes after we perform the scale factor. So from this center, to get to this corner, we have to go up 6. We don't go left or right. So the column vector is 0, 6. What we do now is we multiply that through by the scale factor. So in this case, 0 times minus a half stays as 0. 6 times minus a half is minus 3. So we go back to our center of enlargement here, and we apply this column vector. So 0, we don't go left or right. Minus 3 means we're going to go down 3. This corner is going to go to here. Okay, pick a different corner. So I'm picking this one. So everything's from the center of enlargement. So how do I get to this corner from center of enlargement? Well, I go right 4 and up 6. So I go 4 to the right and 6 up. And again, I multiply this through by the negative scale factor of minus a half. So minus 2 and 6 times minus half is minus 3. Again, return to your center of enlargement. This means 2 left and 3 down. So 2 left and 3 down. So this corner has now moved to this position here. And finally, use a third color to highlight this, the top of the triangle. So go back to your center of enlargement. It's 2 to the right and 10 up. Okay, so multiply both of those values by minus a half. Give me minus 1 and minus 5. So return to your center. Minus 1 is minus 1 left. Minus 5 is minus 5 down. And it goes here. And then finally, just a ruler and just join these corners up. And there's the position after we've applied the scale factor and center. Finally then, upper and lower bounds. We've seen this quite a lot recently. So on this one, I would encourage you to draw a picture to show what's going on. So a triangle's got a base, 24 centimeters, and a vertical height of 14 centimeters. So a vertical height is straight up. Call that 14 centimeters. Join it up to finish my triangle. Because it's a vertical height, there'll be a right angle here. Each measurement is given correct to the nearest centimeter. So we need to go half a centimeter above and half a centimeter below to get our upper and lower bounds, 24, and the same for 14. So the upper bound for this one would be 14.5 and the lower bound 13.5. Now, we are being asked to calculate the minimum and maximum possible areas. So to calculate the area of this triangle, I need to perform this operation, base times height divided by 2. Now, when we multiply here, the numerator, to get the smallest possible answer, the minimum answer, these two values need to be the two smallest values when we multiply them together. So I need to do 23.5 multiplied by 13.5, and not forgetting to divide through by 2. And to get my maximum possible area, I need to use the largest, the upper bound values. So that's 24.5 multiplied by 14.5. Again, don't forget to divide by 2. So on this one, then typing them on your calculator. So the minimum area would be 158.625 centimeters squared. And the upper value, the maximum value, would be 177.625 centimeters squared. Thanks for listening to this video.